inside the circle. Everyone take a look at angle ACD for me. ACD. Is it a central? Nope. Is it inscribed? But is it still inside the circle? Okay, so this is our third and final type of angle we can find inside. Angle ACD. And this is not the official name. This is what I like to call it. Floater angle. Floater angle. Why do I like to call it a floater angle? It's literally just floating in the circle. It has no destination. It's not the center. It's not on the circle. It's just floating in there. All right, just floating. How do you find the measure? It is a lot more complicated than just taking half or the same arc. I'm going to slow it down a little bit here. So floater angle. You're going to add two arcs together for me. Okay, you're going to add two arcs together. You take the arc that belongs to the floater angle. So I'm going to say its arc. So the arc that belongs to the floater angle. And you ready for this? You're going to add its vertical, remember vertical angles? Its vertical angles arc. Okay, so you take the floater angle, add its arc, plus look at its vertical angle and add its arc to it. So it's vertical angles arc. And I wish I was done. Notice I put a little space in there between the equals and the parentheses because you're going to add those two arcs up and take half of that. You're going to take half of that. Go back to ACD. Let's try this out on ACD. Name the two arcs you think I was going to add together here. First, name the arc that belongs to ACD for me. Name the arc that belongs to ACD. 13?
AD.
Good. So I'm going to add arc AD plus, now look at the vertical angle. What arc belongs to the vertical angle? So here's ACD. Look at its vertical angle. What arc belongs to its vertical angle now? 18?
BE.
Good job. BE. Does everyone see that? Here's the vertical angle. That arc angle belongs to BE. Good work. And then I'll be taking half of that. So, okay. Floater angle. Questions? Okay, let's do a couple basics until we get to the big dogs here. Do not assume X is the center. That's not the center right there, okay? I'm telling you it's not. All right, the answer is not 88. But it is a floater. So it's going to be 1/2. What arc belongs to angle X? 3. What arc belongs to angle X? 88. Plus, look at its vertical angle. What arc belongs to its vertical angle? 14. 14, yeah.
86.
86. Everyone all right with those? What are we doing using our calculators for this? You got an 86 on quiz 1 and 88 on quiz 2. What's your average?
87.
Okay, thank you. Thank you. Put those things away. Oh, I never looked at it like that. 87. Basic, right? Basic. All right, now I want you to find the arc instead in number 2. Time out. You're going to hear me say these 3 questions all today. That's 65 degrees. Is it central? Inscribed. So it's got to be floater. Okay, I'm going to ask you those 3 questions every problem now. So 65 floater is equal to 1/2 its arc, 100, plus vertical angles arc, X. How are you guys going to approach this, solving this? Because there's two ways you can go. Let's talk about both ways, and I'm just going to go one of the ways. Zach, what's one way?
Multiply 65 by 2.
Okay, so you want to get the 1/2 out of there. Right? All right, yeah, you can multiply both sides by 2. That eliminates the 1/2. Or what can I do with the 1/2? Distribute it. It's up to you. Me personally, I'm not a big fan. I can see what's going to happen here. 1/2 x. That gets me nervous, right? A fraction with a variable. So I'm going to go Zach's way here and multiply both sides by 2. So you can get rid of the 1/2 and don't have to worry about it. So what are we looking at there? 130? So arc X equals 30 degrees. Floater angle. All right, you ready to step your game up a little bit now? Can we? This is the average level. Can we take it to the above average level now, which this class is designed for? All right, find angle X. I notice X is a floater. Ooh, this has been, it's been a while since I've given you a ratio of numbers here. Usually I did, I think, with angles back in the day. Earlier on in the year, we did it with angles in a ratio. Anybody remember what we did? Well, not part. These aren't I know what you're thinking, but these aren't partitions, though. If 3 angles were in a ratio of 1 to 2 to 3, what did we usually do with them? We didn't write 1, 2, 3. What did we write? 1x, 2x, 3x, right? We put x's with them. Everyone remember that? Okay, so that's what I'm going to do here. But is everyone all right if I don't use the variable x because my angle is x? I'm going to use a different variable. So where I see ABC, everyone look at arc ABC. I'm just not going to put a 2 here. Let's put a 2y. Again, yes, usually I'd put an x with it, but the angle I'm looking for is x, so I don't want to double up there. All right, what am I going to put at CD? 3y. What am I going to put at DFG? 1y. And then finally at AG? 4y. All right. I can't do these. Hey, I can't do this problem unless I know how many degrees those arcs are, though. So what can I do with all 4 of these to figure out what y is so I can plug it back in and figure out what the arc is? Emma? Circle, there's 360 degrees. Isn't there? Good. Perfect. Remember that. Circle, 360, not 180, 360. So 2y plus 3y plus y plus 4y. Yep. 360. Was anybody going to take it a different way, maybe? 2y and 3y would add up to what? 180, because that's a diameter, too. We're going to get there sooner or later. What do I got here, kids? 10y equals 360. Y equals 36. All right, plug it back in now to find each arc measure. So this will be 36 times 2, 72. Times 3, I know we don't need this one in this problem, but times 3, 108. Oh, really, I'm pushing the limits right now. 144. All right, let's find x now. It's a floater, right? Tell me the 2 arcs I'm going to add up. It's a floater. What 2 arcs should I be adding up here? 14. 2 arcs I should add up.
72 and
Okay, 72, its arc, and its vertical angles arc, 36. Good work, everyone. You like that, George? Good talk. You like that? Talking to you, boss. You like this?
Yeah.
Okay, great job. I give you a chance to speak, and you blew it. $54. Questions? All right, I'm going to let you take a breath now. Because I don't think you're in store for the big time now. Stretch out if you need to. King-sized circle problems. That's what I refer to these as. This is where you're going to live from now on. King-size circle problems. Why do I call them king-size? Because we got parts A through E to deal with. Okay? A through E. And I'll start by saying this. I don't care what they're asking for. If you are going to be successful in these types of king-size problems, you'll have to know every arc measure. If you know every arc measure, your success rate will go through the roof. All right, so what I'm trying to tell you is don't do this on your paper, but I don't care what they're asking me to find. Don't care. I want to know what is each arc measure first. Once I know each arc measure, and if I know my rules, this becomes an easy problem. So can you help me find each arc measure right now before I even tackle A through E? Well, let's figure it out. AEH, $1.10. Everyone see A to E to H? A to E to H. That's 110 degrees. Done. AG, 80. Ooh, and there's the ratio again. AE to EH is 2 to 3. So what can I put on AE? 2x. I can use the x's now. 2x. And what are you guys putting on EH? 3x. All right. I'm going to turn it over to you guys now. Can you find me any arc measure up here, please? Any arc measure can you find for me right now? Or help me find? Because I'm going to try to get to all of them. Was there anyone? Luke, you can find one for me? HB. What's HB? Good job. Hey, and this is one thing that drives me nuts when you guys do these problems. Everyone always misses the diameter in the problem. Everyone see diameter AOB? Cuts it into a semicircle, which is how many degrees, Luke? That's how we knew that was 70. That's 110. That's a semicircle, so that's got to be 70. Good. More. Come on, keep feeding the beast here. More. What do we got? Romeo, go. GB 100. Same exact reason. Diameter broke it up into 180 degrees. Good. We're getting there. What's the deal with the 2x and the 3x? What can I do with that piece? Add them and set them equal to? Not 180, not 360 this time, but $1.10. Come on. 5x equals 110. X equals, who boy? 24? 2 or 2, that works too. Yeah. All right, plug it back in. So what do I got, 44 and 66 here? I think I found all the arcs, didn't I? All the arcs are found? All right, we're ready to get after it. Now it's going to test your rules. Now you're going to be tested on, do I know my circle rules or not? Part A, what's the measure of arc GB? Oh, geez, we already found it. That's what's going to happen most of the times. The first 1 or 2 letters in this question are going to be solved for already. 100 degrees. Oh, part B, already solved for. Measure of arc EA. What do we got? 44? All right, you ready? Do we know our rules or not? Angle EFA. Look at it. Look at it. Ready. Central. No. Inscribed. Nope. Floater. All right. See, there we went right down the checklist. Floater. 1/2. And somebody's going to tell me what 2 arcs I should be adding up. Yeah, come on, come on. 11. What arc belongs to EFA? 44. Now look at the vertical angle to EFA. What arc belongs to that angle? 100. Yes. Half of 144. What do we got? 72. When you find an angle, put it in the diagram. Put it in the diagram because you never know. Maybe you blank and you don't know a circle. Like, hey, for instance, hey, everyone, oh, stop, time out. Let's say, I know this question's not going to be asked, but let's say I had to find angle EFB. Everyone see EFB? And let's just say you totally blanked, didn't realize it was a floater. Could you find it some other way? Now you know this is 72. Could I find EFB another way without even touching floater angles? What's the relationship? So yeah. All right. Don't get in the mindset I always need a rule. No, you don't. Use some geometry too sometimes. All right. Don't assume you always need a rule. If you can find it another way, go for it. What's D? FEB? Central. Inscribed. Yeah, we got an inscribed angle, don't we? So now you got to remember the rule. What is the rule for inscribed? Half its arc, right? So everyone take a look. FEB, figure out what arc it's drawn to. What's the arc measure it's drawn to? 11? 100. It's easy when you know the rule, but it's not necessary. Hey, it's not necessary. Maybe some of you blanked and you didn't know that was inscribed. Do you see that it's part of a triangle here? Maybe you found these angles here and then you subtracted them from 180. I'm just trying to get you guys out of the mindset, I always need a circle rule. No, if you can find it some other way, go for it. Let me put 50 in there. May need it. You never know. And then ready for, what do we got? E. Oh, I love this one. Kids go nuts on this one. They have no idea what's going on. OHD. Oh, no, OHD. Oh, I got it. Yeah. Follow the letters, Carl. Central? Inscribed? Some of you may be shaking your head yes, because H is on the circle, but is DH a chord? Is OH a chord? That's not inscribed unless they're chords. Remember, that's not. Is a floater? I got nothing there. It's not central, it's not inscribed, it's not a floater. But I'm still asking you to find it. So there's got to be something you know. Something you know to find that angle, even though it's not one of the three we discussed. It's got to be something. Think you got it, Ellie?
Tangent.
What about it?
DH.
DHC is a tangent. What's OH? And what happens when the two meet, ladies and gentlemen? What do you get? Perpendicular, and we get a right angle from there. There you go. There you go. You'll have something to find it. Any questions there? Your first king-size circle problem. Cal, not that bad. Okay. Anybody want to ask anything? Because one doesn't make you great. You need to be fed a little more here. Please do not just skim over the directions, because there's one given here that's pretty important that I think many of you are just going to skim over. Okay, the triangle's inside. It's inscribed. AP bisects angle BAC. So I'm going to ask one of you guys, what two angles are now congruent? If AP bisects BAC, what two angles up here are equal? One, hello, George.
BAE and EAC.
Way to not mess it up. Good. I had faith in you. Those two are equal whenever I find it. Oh, numbers in a ratio again, but not for arcs, for angles, right? For angles. So angle ACB, I can throw a 2x there. CAB, let's throw a 3x. Oh, that's the wrong one. 3x. And ABC, let's throw a 2x on there. What are you guys doing now? Remember, those aren't arc measures. Those are angle measures. So can I add them up? Yes, but now set them equal to what? Good, good. There you go. Because they're angles in a triangle. Why did I put 2? I should have put 4x. Yeah, I know. All right, let's plug it back in. Let's see, this will be 40. Everyone all right? Going too fast? Now I'm getting X, and now I'm plugging them back in. This will be 80. Angle C will be 80. Angle BAC will be 60. Is everyone all right if I just put what for each angle that it gets bisected? Everyone all right if I go 30-30 on you? Where that's coming from? All right. Before we begin, just a little to get you going. What type of angles are those? Like angle B, angle C. These are all what? What type of angles are those in the circle? Inscribed, right? So keep that in mind as we go through this problem. They're inscribed angles. Okay, first part. What's angle ABC? Oh, you're welcome. That's already done, right? 40. Ooh, how about arc BF? How can I get to BF now? Now I'm asking for arcs. Something we found will help you. Is look for any angle drawn to BF, right? Look for any angle that might be drawn to BF. Anything? Anybody see an angle that's drawn to BF? 16 thoughts here?
Is it angle AEC?
AEC? Okay, that's a floater. I want to try to get there a little bit more direct though. Do you see angle BAF? That's 30 degrees.
Yeah.
Okay, that's an inscribed angle, correct?
Mm-hmm.
So what do I have to do with that 30 to get to the arc it's drawn to? This angle right here, BAF, is an inscribed angle drawn to arc BF. So I know the inscribed angle's 30. How would I find the arc then?
So does that mean if that's the arc, does that mean like that's also 30?
No, that's central angle.
Oh, right. Half of.
Okay, 30 is half the arc, correct. But I'm finding the arc now. So I don't want to take half of 30. What do I want to do instead? Ready? How did I find this 30-degree angle? Inscribed angle is equal to half its arc, right? So 30 was found by taking half of whatever BF is. So what number would I have gotten but taking half of to get 30?
Oh, what number? What was half of 30? Half of 30?
I know what half of 30 is, but what number? Here you go. What number up here did I take half of to get that 30? So I'm doubling the inscribed angle to get to the arc. See that?
Okay.
Yes, maybe? Inscribed angle is equal to half its arc.
Oh, yeah.
I knew the angle already, so instead of taking half, I'm going to go in reverse and double it to get the arc. All right? And then angle BEP. Look at that angle, BEP. What type of angle is it? 9. What type of angle is it? Do I have a 9? No 9? All right. How about an 18?
No.
BEP. Central?
No.
Inscribed?
No.
Floater?
Yeah.
Okay. It is a floater angle, but I'm going to tell you guys, you don't have to find it that way. Find it however you want. Go. Find however you want to find BEP. If you want to do floater angle, do floater angle. If you rather do it some other way, do it some other way. Hopefully I'm driving that point home to you guys that if you don't see it using a circle fact, find another way around it. Start just filling in angles you know, and eventually you get there. If you did use floater, it would be half of its arc, 60, plus its vertical angles arc, which would have been AC. Anybody know what AC is? What the measure of that one is? Here's the inscribed angle 40, so what's the arc? 80, so you could have used a half, a 60, and 80. Anybody do, this is 30, that's 40, so that's got to be 110, and that's supplementary to it, so that's 70. Or maybe some of you did, that's 30 and 80, that's got to be 70, 180 degrees in a triangle, and those are vertical. I don't care. Whatever gets the job done. And that's what you're doing tonight. Hey, do not give up on a problem. Look around to find different angles that are next to it. Get started. You can get started on it now. We still got 7 minutes, and it's in the packet. Do not give up on a king-size circle problem. Just find angles around it, and you'll get there eventually. It's okay not to have a circle rule for it.